Hello, and welcome to today's lesson on electrical work as a method of energy transfer. Today, we will explore how electrical work serves as a method of energy transfer and examine a real-life example to understand how electrical work is used to transfer energy and perform tasks. In our previous lesson, we explored the concept of energy transfer, understanding that energy can move from one place to another or change from one form to another. These processes always obey the principle of conservation of energy. By now, examining how energy is transferred through electrical circuits, we will deepen our knowledge of how energy is used to perform practical tasks in everyday life, further enhancing our understanding of energy transformations. One method of energy transfer is electrical work. Electrical work is the transfer of energy through the movement of electric charges. To understand this, think of electrical work as similar to the flow of water through a pipe. However, instead of water, it's the flow of tiny charged particles called electrons. In electrical circuits, these electrons move through wires and other components, transferring energy as they go. The potential difference across a component, a concept we'll explore in detail later, drives these electrons through the circuit, doing electrical work in the process. This work can be used to perform various tasks, such as powering lights, heating elements, and motors. To see how electrical work transfers energy, let's use the example of a flashlight. When you switch on a flashlight, the battery inside starts to work. The battery contains stored chemical energy. The chemical energy in the battery gets converted into electrical energy, causing electrons to begin moving. These electrons flow through the flashlight circuit towards the bulb. When these electrons reach the bulb, they encounter a thin wire called a filament. At this point, imagine that the electrons are like a crowd of people trying to get through a narrow hallway. As they pass through the thin filament, they have to squeeze close together. This squeezing through causes the filament to heat up, similar to how a narrow hallway would get warmer if too many people passed through it at once. The heated filament reaches such a high temperature that it starts to glow, producing light. In this process, the electrical work done by the electrons transforms the chemical energy stored in the batteries into heat and light energy in the bulb. Through this, energy was transferred from the battery to the lamp. In today's lesson, we delved into the process of electrical work as a method of energy transfer. Specifically, we saw that electrical work involves the movement of electric charges with energy being converted into other forms like heat, light, or mechanical work. To illustrate this, we looked at an example, powering a light bulb. We broke down how electrical energy from a power source, like a battery or generator, travels through wires and is converted into light and heat energy in the bulb. This example helped us understand how electrical work effectively transfers energy and is integral to many everyday applications. In summary, grasping the concept of electrical work and seeing it in action through examples allows us to appreciate its critical role in various technologies and our daily lives.